And after that, we are going to have test 2 on the 15th, and the final when 20
26.
26
26.
27.
27.
Okay, 27 will be the final. So the final exam question already ready, and test 2 question also will be 2 questions. Question number 1, that one Dr. Azizi is preparing. I don't know what is the question. And question number 2, I prepared. There will be 2 parts. Part A is about the timing diagram, and part B is about designing logic circuits. I give you the problems, and what you do is that you have to design starting from the truth tables. You normalize, you simplify the truth tables. Then after that, you draw the simplified logic gates, logic circuits. So it's quite similar to the to the final later, right? So my test 2, basically that test 1 will be similar to question 1 and 2 in the final. Test 2 will be similar to question number 3 and 4 in the final. So hopefully you'll be able to score for this particular subject, right? And today we are going to cover on the microcontroller and microprocessor. So my lecture will be a short one. Then after that, if we have time, we will discuss on some of the examples, simple sample questions. Okay. So now I'm going to share the slides. I'm going to share my screen too. So everybody see the, what do you call it? The screen. Digital electronics, microcontroller and microprocessor. You can see? Or no?
No, sir.
Nampak tak?
No, sir.
Freeze.
Ha?
Freeze.
No.
Ha? What did you see?
Saya nampak Pikachu ni.
Apa yang you nampak? The screen. Oh, so basically I share a different.
Kau.
So I share a different screen. So now I'm going to share.
Hitam apa ni?
Okay.
Hijau dan hitam.
No, let me. Okay, now I'm going to share. Okay. Can you see? Can you see the screen now? Can you see the screen now?
Yes, sir.
Okay. Now you can see the screen, right? Oh, oops, okay. Now you can see the screen. Okay. This is actually chapter 12 of the Floyd Digital Fundamental textbook. It's on microcontroller and microprocessor. So they just an introduction for you, so that when you go into succeeding semesters, if you need to study in terms of the controllers and whatnot, to control your mechanical arms and whatnot, at least you understand what is the microcontroller and microprocessor is all about. Okay, this is a block diagram of a computer. Any computer, basically, that you have this. Okay, you have the CPU. You have the uh, uh, the computer. This you have your motherboard, which is consists of the CPU. Okay, you have the CPU, central processing unit. You have the memory. We cover last lecture on in the memory. You have the input and output ports. Then you have we cover on address bus. Remember, and we cover on the data bus last week, and we have a control bus, right, to control the CPU. And of course, input and output. We have the input, basically that from the keyboard. Okay, is the input. The mouse as the input. Okay. Then you have the monitor as the output, basically to display, and you have the printer as the output to print what you have, and also you have this as the also as an input and output, which is the storage also. Can be to read and to write the data, the external data into the computer. And also you have the modem, which is for the communication. So this is the block diagram of a computer. You have all this. Any question on this? No. Very simple. So actually that whether it's a desktop computer, whether it's a notebook, you have all this similar to this. Even actually, even if you have a smartphone, also is some sort of a computer. You have all this. You have all these components, right? This is the block diagram of a microcontroller and microprocessor. The top one is a microcontroller. And the bottom one is the microprocessor. You see any different? You see any different?
Ada.
A microcontroller,
Tak ada je.
you don't see. No
You
different.
see UP.
Apa siut?
What about the what about the red dotted lines?
Ada
You see
red tu
that?
lah. Nampak?
yes.
Okay. Microcontroller is basically that everything is in one package. All those in the red one is everything in one package. So that is microcontroller. And the bottom one is microprocessor, where the peripherals and memory is separated from the CPU. So these are the components of microcontroller and microprocessor. They have exactly the same components. CPU, they have the CPU, they have the I/O, input output, they have buses, they have memory, timer, which is the clock, interrupts, they have serial port and parallel port. Those are the components of microcontroller and also microprocessor. Same component. This is the general purpose microprocessor, or we call it a computer on a chip. It's a LIDAS. It's a general purpose central processing unit fabricated on a single integrated IC, and it's a complete digital computer. It's small but powerful electronic brain that operates at a blistering speed and is often used to carry out instruction of a computer program in order to perform arithmetic and logical operations. Also to store data, systems control, input and output operation as per the instruction. The key terms in defining the microprocessor is that it's a general purpose. It can be used for a lot of applications. on a wide range of applications. So that's why we call it general purpose microprocessor. The first microprocessor was from Intel, released in 1971. It's called 4004, a 4-bit microprocessor. The general purpose microprocessor basically that act as a CPU for the computer. And commonly there is no RAM or ROM or IO on the CPU chip itself. Okay, so basically that if you look at the previous, this one, okay, if you look at the microprocessor, the peripherals and memory are outside of the CPU. So it's not integrated with the CPU. Whereas for microcontroller, peripherals and memory actually integrated with the CPU. You see after this. Okay. So you have the CPU, microprocessor here. Then you have the data bus and address bus, connected the RAM, the ROM, IO ports, timer, and serial ports. So there will be basically that many chips on board. So on one memory board, so you have the CPU, the general purpose microprocessor, you have the RAM chip, you have the ROM chip, you have the IO port chip, you have the timer, the clock, you have the serial ports and parallel ports and everything. Basically, so basically that is many chips on the motherboard. That is the general purpose microprocessor. This is the block diagram of a microprocessor. So you have ALU, arithmetic logic unit, you have the registers, and you have the control unit. Okay, then you have the bus, system bus, which is involve control bus, data bus, and address bus. And it goes connected to the output device and input device. So this is called IO device, which is keyboards, mouse, and monitors. And you have the memory, which is RAM and ROM. So all connected to the bus and connected to the microprocessor. These are the block diagram of a microprocessor. This is the internal structure of a microprocessor. In the microprocessor, you have ALU, arithmetic logic unit. You have the instruction decoder. The instruction is basically that it's written. Normally, we write programs in a high-level language. For example, in Visual Basic, for example, Java, or in C++ or C#, for example. Then that high-level language will be translated into the assembly language, which is the language which are using symbols. For example, if you want to move data from one register to another, maybe you use the word MOV, so to move. But that is actually still the computer is not able to understand that instruction. So it needs a instruction decoder. So it decodes that instruction into a machine language, which is in ones and zeros. So move can be, the instruction can be 1001, for example. That indicates the move. So the instruction decoder will see 1001 and it will say that, okay, this is actually that I need to move data from one register to another register. So this is the instruction decoder. Arithmetic logic unit is to do the adding, subtracting, multiplying, and division. Then this register array is basically to store data. So it can be many registers here that you have the data. And control unit is to control the behavior of the microprocessor. Okay. So this is actually the connectivity within the microprocessor. Processor. You have a control bus, you have data bus, you have address bus. Here, actually, you have the program counter. Program counter is basically that to move from one line to another line of the programs. You have the status register. You have the accumulator. This is the arithmetic logic unit. So data is basically that. You take data to the accumulator for you to do the arithmetic logic. This is the instruction register, control unit. So these are the internal structure of a microprocessor. So I'm not going to go into detail because this is not your core subject. So at least you understand what is the components or the internal structure of a microprocessor. This is the architecture. Architecture basically that you have von Neumann architecture, where you have the processor and you have the program memory and data memory. So it's exchange the you have the connectivity here, two-way connectivity. This is the hardware architecture of a microprocessor. You have the processor, then you have the program memory and data memory. So it's separated. Von Neumann, basically that is together in the memory. Okay. This is the Intel 8088 microprocessor. You have two units actually under in the microprocessor. You have EU and BIU units. EU is execution unit, which executes instructions, and another unit is bus interface unit, which is the function is to fetch instruction, to read the operand, and to write the result. So these two work together, and this system buses actually connects to the outside world of this microprocessor, which is to the RAM, ROM, input ports and output ports, and the modems and whatnot here. So this is the internal structure of the Intel 8088 microprocessor. In the EU, you have the general register, which is register A, which consists of AH and AL, which AH is the higher byte, and AL is the lower byte. So you have register B, same, high and low, register C and D. Then after that, you have the SP, BP, DI, and SI. This one, all this you can read in the textbook. What does it mean? Which is the pointer and index and all those kind of things. And you have the temporary register, you have the ALU, and you have the control unit. So this is actually under the EU, the execution unit. Under BIU, you have the summer. You have the CS, DS, SSES, IP, the internal communication register, which this is actually to control the communication and whatnot, just like this to fetch instruction, reads and write. So this is the instruction queue. For example, you have the first instruction, second instruction, third instruction, and fourth instruction. So it queue up the instruction to be executed by the EU. So this is the bus control logic. So this is the system bus. Now, what is a microcontroller? So the microcontroller is actually all sits on the whatever that you have in the microprocessor. It put into one single chip. The main reason for the development of microcontroller is to overcome the only drawback of microprocessor, which requires external chips like RAM, ROM, input-output ports, and other components in order to design a complete working systems. So microcontroller is basically to put everything on one chip. In microprocessor, you have the processor, then after that you have other external ICs that you need to put together in order to make it work. Whereas microcontroller, everything is already on that one single chip. So the first microcontroller was developed in 1971 and released in 1974 by a Texas Instrument, which is called TMS 1000. It's a single chip computer, and it has on-chip RAM, ROM, and I/O ports. Other examples of microcontroller, basically that you have Motorola 6811, okay? You have Intel 8051, Xylox Z8, and PIC 16X. So those are the examples of microcontroller, and you have many more. And it's actually everything in a single chip. Yes, Hafiz?
Faham,
Any question?
No, sir. Setakat ni.
Sir,
Macam
Profesor.
sejarah.
Okay.
Sejarah, sir.
Processor tu macam Ryzen IC semua tu lah.
Processor
Ah,
is basically that is an IC, integrated circuit, but it has a certain component in it. A processor, a microcontroller, or microprocessor, it has to have CPU. Okay, this component must have this CPU. Without the CPU, it's not a microcontroller or microprocessor. For microcontroller, okay, microcontroller, CPU, RAM, ROM, I/O ports, timer, and serial com are all in the same chip, same IC, in one single IC. Whereas microprocessor, you have the CPU, separate IC, RAM separate, ROM separate, I/O port separate, timer separate, serial com separate. So it's not in one single chip. That is for microprocessor. Microcontroller, everything in one. Okay? That's the difference. This is the block diagram of a microcontroller. So this is actually on one IC. This. So on this IC, you have the CPU. You have the interrupt control. You have the oscillator, which is for timer, clock. Then you have the memory, flash memory. You have the RAM. Flash is flash ROM. This you have the RAM. Then you have the bus control. And you have the ports. Then you have this also timer, counter. This is the clock. This is the timer. So this actually everything in one single IC. In summary, basically that this is the comparison. Okay. Microprocessor, see this. You have the ALU, register, and control unit. And in the microprocessor, they have only this: register, control unit, ALU. Microcontroller, everything is on the chip, which is CPU, CPU. This CPU is basically this. You have this. It's here. So this part actually is inside here. Then it has I/O ports, counter, timer, ROM, and RAM. If it's microprocessor, the I/O ports will be here. the counter here, timer also here, RAM here, ROM also here, which is all outside. Whereas microcontroller, everything in here. And there is the comparison. CPU is standalone. RAM, ROM, I/O, timer are separate IC. Whereas microcontroller, everything is on a single chip: CPU, RAM, ROM, I/O, and timer. Microcontroller is designed. Designer can decide on the amount of ROM, RAM, and I/O. You can have so many ports that you want. So that's why when you sometimes if you buy the notebook, for example, some of them only have 2 USB port, right? Some have 3 or 4. So the designer can decide how many I/O ports that they want to put, and also can decide how many RAM, how many gig RAM that they want to put. Whereas for microcontroller, it fixed amount on the chip. If it's 4 port, then it's 4 port. You cannot add any more. RAM, if it says that it's they have a let's say 64 meg, and you cannot add anymore. So microcontroller is fixed amounts. So when a designer want to decide what controller to use and what not, he has to understand the specification of that particular microcontroller, whether it fits the use for that what to call it purpose or not, right? Microprocessor is expensive, whereas microcontroller for application in which cost, power, and space are critical. So basically that the microcontroller is cheaper and is smaller in size and also consume less power. Because remember, the microcontroller that you want to put this microcontroller in the very confined space. Whereas for microprocessor, normally you have a bigger space. And microprocessor is very versatile. It's very versatile. Can be used for general purpose. Whereas microprocessor is a single purpose or control oriented. It depends on your application. Certain application, maybe, for example, you use PIC, or certain application you can use Zilog. In terms of processing power, microprocessor has a high processing power and microcontroller low processing power. Microprocessor consume high power, microcontroller consume lower power. And microprocessor is an instruction set focused on processing intensive operation. Basically that you want to do number crunching, which is you want to do parallel processing and whatnot. Heavy mathematical calculation. So it's a microprocessor. Whereas for microcontroller, it's a bit level operation. Which is at the lowest level of operation, ones and zeros, on and off. And typically, for microprocessor, is 32 or 64 bits. Whereas for microcontroller, is 8 to 16 bit microcontroller. And it has deep pipelines, 5 to 20 stages of pipeline. And for microcontroller, typically single cycle or two-stage pipeline. So this is actually the comparison of the microprocessor and microcontroller, right? Any question? So if I ask you, let's say the computer in your microwave oven. Is it a microcontroller or microprocessor?
Microcontroller.
Controller je.
Microcontroller. What about in your laptop?
Depends.
Microprocessor je.
In your laptop,
Depend on microphone.
if it says Intel inside,
Microprocessor.
huh?
Microprocessor kot je. Kot je.
Microprocessor. It is on
Betul je.
your notebook is microprocessor.
Sebab
On your handphones,
micro
on your
Controller.
handphones now, the
Processor.
smartphone.
Microprocessor
The
je.
smartphone now is basically microprocessor.
Oh. My phone not
So
smart,
that's
sir.
why you can have
Nothing, sir.
the smartphone. Basically, that you have the ability of having the memory card, for example. Those are actually the microprocessor already. They use microprocessor. But if you use the Nokia, the old Nokia, whatever 3310, where actually you can just make calls and receive calls, no internet, nothing. So that is you use microcontroller because everything is actually fixed. How many memory that you can, how many message that you can store in your phones, how many phone number, the contact number that you can store in your phones. So those normally is microcontroller. But the smartphone now is mostly a microprocessor, where even you can upgrade. You can put in, you can buy a memory card. 1 gig, 2 gig memory card you can put in. Right? So from that application, actually, you can guess what kind, whether it's microprocessor or microcontroller. If it's a special purpose, then it's most likely is a microcontroller. If it's multi-purpose, smartphone now it's almost multi-purpose because it can be a camera, it can be a TV, radio. So those most probably is a microprocessor. Right? These are some popular microcontroller. 8051. You see, this actually everything is in this one chip. Everything inside there. Yes, it's about 3 inches. Yeah. Even now, let's say it can be even smaller than this. This is old.
Benda ni bukan yang ada
This is
kat
actually
Arduino
old
tu kan?
photo. Yes.
Oh.
Arduino tu basically is a microcontroller.
Ni lipan ni lipan.
Lipan.
So this is a microchip technology PIC at Bell, Texas Instrument MSP 8430. So that hardware will not be able to do anything without programming. So how do you program this thing? So basically that when we talk about programming, you need to know about the level, the hierarchy of programming language. Okay, the highest level, the high level programming language is very close to the human language. For example, let's say Visual Basic, right? Visual Basic, C++, Java. Anybody knows programming?
Python je.
Anybody?
Don't know, sir.
Huh?
Sikit-sikit je.
Huh?
Sikit-sikit.
I
Buat
don't
BMI boleh lah sir. Lain tak boleh.
What kind of programming language that you know?
Python.
Python. Okay, that is actually high level language.
Oh.
So that is high-level language. So it's closer to human language. Then it goes to the down one lower level is assembly language. So English-like term representing binary code. For example, MOV means move. Or LOAD, load. Or ADD, add. ADD, add. So it's also machine dependent. Some machine will not understand what is MOV because the programmer or the designer of that particular controller use MV maybe for the move. Then if you go to lower level, which is called it machine language. Machine language basically is that it translates the assembly language into binary codes, ones and zeros. That is also machine dependent. It depends on the IC. Then, if you go for lower, then basically you go into the hardware level already, which is one maybe voltage 5 volt or 2.5 volt. Zero is maybe minus 5 volt or minus 2.5 or maybe zero. So those are actually at the CPU, memory, disk drive, and all those level already. In the CPU, it just recognize the voltage. 5 volt as 1, 0 volt as 0. So that is the hierarchy of the programming language. Right? Do you want the example of how the assembly language looks like? Machine language looks like? If you want, I can give later. I don't have in the slide right now, but I can give later. Right? So this is the hierarchy of programming language. So this is how you want to convert the programs into machine language. If you are using the high-level programming language, you have a source program, right? Then basically that you need to compile to make it, to translate it into machine language. Apa yang tak apa ni?
Apa sir?
Apa yang tak off? Okay.
Mute.
Mute. Okay. Okay. The compiler basically has to convert the high-level programming language into machine language, into ones and zeros. So we call it compiler. So that's why you have to compile your high-level programming, high-level program. For the assembly language, we don't compile, but we call it assemble. So you use assembler. So from the assembly language, the source program we assemble to turn into machine language. So that's the conversion, how you convert the program so that the machine can understand. So, what are the main differences between microprocessor and microcontroller in terms of the architecture? Anybody can answer? Basically, that the microprocessor, in terms of the architecture, is that it's not on it's on a multiple chip. Yeah. So basically, CPU is a standalone. Then after that, all the timer and everything has a separate ICs. Whereas for microcontroller, everything is on a one single chip, single IC. In terms of the application, microprocessor is a multi-purpose or general purpose. It has a wide variety of applications that can be used. Whereas the microcontroller is a single purpose usage. The instruction sets. The microprocessor, basically that mostly you use high level programming language. Right? It's a complex instruction set, English-like language. Whereas in the microcontroller is simplified, is a in the form of assembly language and a simple instruction set and works with ones and zeros. Okay, a bit operation. Okay, simple. We are done. Any question on the microprocessor and microcontroller?
Microprocessor
Any
lebih
question?
kepada memori kan, sir?
No, microprocessor is a general purpose processor. It's not only based on memory. It's actually it can do complex operation. Memory basically that is you can add. Is not limited to the one that is provided on the chip.
Oh, patutlah dia boleh carry 32 bit. Faham ke? Berbanding
32 bit
microcontroller.
or 64 bit, that is because of the CPU of the microprocessor, which is designed that way. Whereas the microcontroller is 8 or 16 bit processor. Because because the microcontroller, the usage is for a single purpose. So dia punya terhad memang is a special purpose kind of IC that you use. Maknanya you tak boleh buat banyak benda. Kalau nak control washing machine, you design untuk washing machine, untuk control washing machine. You tak boleh dah nak the same program you nak buat you use in television. So that one you have to program and burn into the program burn into the microcontroller and use for that particular purpose. Whereas for microprocessor, you can do a lot more things. For example, let's say the microprocessor in your notebook, you have a lot of applications there. It can be turned into a television if you want. Just write a program and put it there. Or you just download the programs. Okay, what else? Ada soalan lagi? Tak ada soalan dah. Anything? Kalau tak ada, I stop the recording for this because I have completed on the microcontroller and microprocessor, and we start other a new recording. Okay.